Hi, welcome to the Air Manager API tutorial video series. In this video we're going to be looking at hardware again, this time specifically message port. So here we are on the API page again. Message port is right down the end here in the hardware section. A message port is a little different to the rest of the hardware functions that we've already covered in the previous videos, in that you have to flash your Arduino in a different way. So you don't use the installer as normal. So let's go to the Wiki page here, and you can see on the hardware Arduino link here, we go to the Arduino page, and previously we would have used the installer here to do a standard Arduino install. With message port that's a little differently, because what message port enables you to do is you're not using the standard API functions to control the elements of message port, but it does enable you the flexibility to interface with hardware that Air Manager doesn't currently support natively. So you can use I2C and lots of the other ports to interface with different hardware that's not natively supported. So essentially what you're doing here is you're using the Arduino IDE to flash the Arduino, but before you do that it goes ahead and explains what you need to do here on the Arduino hardware page here. And you can download the message port library. You have to import that library into the Arduino IDE, and you have to move some files that come as part of that zip that you download into some locations within your Arduino install. Now when I did it, I've got the latest version of the Arduino IDE. I think it's 1.8.5 or 1.8.6, something like that. This one here says if it exists. Well, it didn't exist, so this one I didn't actually move, but the other two, yes, the platform.txt to this location and the Arduino Builder exe to this location. So you have to do them. Then you import the message port zip, as I spoke about before, and then you can use all those inclusions in that library to flash your Arduino. So let's just open the Arduino IDE. I'll have it open here very quickly. And there's a basic example that you can use. I've tailored it a little bit, the code in here, and that's the beauty of message port, that you can change it to do what you want. Now we're not going to do anything too advanced in this video, but just to show you how Air Manager communicates over the message port, and it can open up the possibilities of sending data both ways, both to the hardware or read from the hardware back into Air Manager. So looking at the basic example, or this modified version of the basic example, I've got a couple of little setups and examples of code both in the Arduino code here and also Air Manager. So we're gonna look both ways. We're gonna send some data from Air Manager to the Arduino, and we're going to send some data back from the Arduino back to Air Manager. So essentially you start, you see I've got just a few definitions here. You call up, you include the message port library there, and I've got the setup of the message port here. So it's essentially done here on this one line. There's a couple of pin setups that I'm using for an LED and a button, just to show some interaction. But essentially it's you set up the new message port. We've given it the name message port here. SI message port device Arduino Mega 2560. So that is what will appear. Sorry, that is what you're flashing, should I say? The Mega 2560. You also do a similar thing in Air Manager, and that is what will appear in the devices tab of Air Manager when we get on to looking at that. So similarly to how you set up the channel with the standard Arduino installer, is you tell it what channel you want this message port. So again, you have the possibility of connecting several of these if you need to. So we're again using channel A, SI message port channel A, and then the callback that is going to be called whenever new messages are received. So we've just called it new message callback as per the the basic example that's provided. So you can see that new message callback is up here. So this is our function, new message callback. You can see what gets returned is a message ID and a payload of data there. There's a struct for that, and these are the members of that struct that gets returned as part of payload. So you can look at the type of data that's coming back. So that'll be, is it an int, float, a byte, string, etc. The length, and then one of these data types. So it'll be either an int, float, a byte, or a string. And then so you can use this payload as that's returned as part of this to strip out that information that's being sent back from or being sent from Air Manager. And it's a similar deal on in the other direction, which we'll get onto in a minute. So essentially what we've got here then is we've got basically saying I've got I'll open Air Manager or the code window for the instrument that we've got in Air Manager in a minute, and we've got a couple of messages set up as a couple of examples. I'm just using, you can use whatever IDs you want here. These are just int numbers. I think they're 16-bit, I think. So you got this number can be up to 65, whatever it is, 536, 535. So I'm just using the IDs of 7 and 8 here, just to saying that that's an individual message ID for one particular set of data, so you can see that you wouldn't run out of IDs in terms of what you were trying to communicate with. So in this particular case, the message ID I'm using to send some ints from Air Manager, and then message ID 8 I'm using it to send a string. So I'm just giving a couple of examples of the different types there. So what we do here is essentially we say if we've got an LED set up, the hardware, actually not an external one, but you can see the mega down here in the video in the corner here. So we're going to use the internal LED, which is around about here somewhere, and we're going to use a button on an Air Manager gauge to turn that LED on and off. Now obviously you could do that using the standard Arduino installer, but it's just to demonstrate how you send the data, and obviously you wouldn't use it for turning the LED because you'd use the standard one for that. But if you were doing more advanced functions, for instance, you could send a byte of data to a DAC, for instance, or maybe a digital pot that might need a 16-bit value, so 2 bytes of data. So you can control all that other hardware using this message port library. So yeah, so we have, as I said, we use the internal LED, and what we're doing with that LED is we're just going to toggle it based on the state of a message that we're going to send from Air Manager over the message port. To turn the internal LED on the mega that we've got here today. So okay, so that's essentially what the first one does, and then here it just basically sends it sets the LED depending on the state of the received data int. Now we're saying you see here this looks like it's an array type value, so we're actually sending 2 ints just to show how you would send them in an array, but you could send a singular one. So we're just saying we want the first one there 0, as it is in Arduino. So the first piece of or the first int as part of that message, that'll either be a 1 or a 0, so we're just saying we want to send that 1 or 0 to the LED to either turn it on or off. And at the same time, if we receive that message 7, we're just going to print a little debug message. So one of the other abilities that message port has got, and that was added, is the ability for debugging purposes to send messages back to the Air Manager console, so you can essentially use these to help you while you're debugging and developing. So you just use this line here. Again, our message port, which is referred here. So we're basically saying we want to send a debug message. We want to send it, there's about 5 different types, so you can see I've got a few set up here. In fact, what we'll do is we'll just uncomment them once, just so that you can see them come through when we do our example, and then we'll comment them out again. So you can see we've got the one called here called debug, another one called trace, another one called info. They essentially do the same thing. They're just sending information to that debug window. In fact, all of these do. They just send a string, essentially what you want to send. So you can see here I've just got the words warning and error. These particular ones that are warn and error, they just use the little graphic that comes up as if you would be getting a normal warning or an error in your instrument code within Air Manager. So you get the little, I think it's yellow warning triangle for a warning, and then you get the red little icon for an error. So I'll just put a couple of those in there just so you can see how they come through. But the other ones are essentially the same. It doesn't really matter too much if you use the trace, the info, or the debugging. So I'm using all three here just to show you. And you can send just straightforward string here, as I've got here, the word warning and the word error on these ones, or you can use some data. So we're extracting the data, or the type and the length, out of that payload struct that was declared up here, and we're just going to print those back to the message port just to show you what sort of information is stored. So the type one will just give you the type, and the length will give you the number of pieces of information that have come over. And then further on down here, we're using the actual the data itself. This one's an int, this one's a string, so that actually prints those actually returned values back out to the Air Manager console, even though they're being received by the Arduino. So very useful for debugging purposes, the debug message. And then in the other example that which we'll do in we'll reflash the code the Air Manager instrument, and we'll send some message on using IDE, and then we'll send a string, and you'll see how the basically whenever we receive a message with the IDE, this little bit of code just literally prints out whatever we send. And it sends it back to the it receives it, and then it sends it back to the console in Air Manager, just so that you can see it. But you don't obviously have to send it back, but this is just for the purposes of demonstration. You would do something with that data normally within the Arduino. So if that was say I don't know, some kind of graphic display, you may want to send some text, and you might want to use that graphic display to actually appear on that graphic display that's connected to your message port. So that's the receiving part of the code. The sending part is essentially down here in the main loop of the code. So essentially, what we've got a button reading function here that's got a little bit of debounce in there, and essentially every time that pin that we're using for that button changes state, I've just got a little wire here. Just there, and we're going to push that into one of these pins, one of these IO pins in a minute, and every time that changes state in terms of going low and high, it should toggle this this write that we've got set up. So we're just sending a payload of 8 bytes here, and we're just going to send 0, 1, 2, 3, 4 all the way up to 7. So just an example of showing it. And then in the Air Manager instrument, we're going to print what we receive to the console, just so you can see how, again, within Arduino, if that was some other bit of hardware that was reporting information, whether it be a series of bytes or just 1 byte or however many, you could send all that information back to Air Manager and then act upon that data within the Air Manager instrument. And then these are just some commented out examples of the other types of send messages that you can create. So this particular one is just creating a payload of an array of 8, and then it's just sending those bytes out using this message port send message. But you can send a string or just an integer or a float. So they're that's essentially the sending function. So what we'll do is we'll go ahead and now the important thing to note here is that when you've probably got this on the same machine as what you've got Air Manager on, so there will be a conflict of the Arduino. So while you're flashing your Arduino, you need to make sure that Air Manager is off. So you need to close down Air Manager so there's not a conflict with the USB of the Mega, or any Arduino for that matter. So while you're doing the flashing here, you want to make sure that Air Manager is off. Now, one other thing just to check very quickly up here is that obviously you need to, as in the normal Arduino way, make sure that you've got the correct board selected. So we've got a Mega 2560 here, that's correct, and then that you choose the right COM port that your device is recognized as. So in this particular case it's COM5, so I've got COM5 selected. So we'll go ahead and upload this now. It should compile okay. It's uploading now. You can see the little flashing lights on the board there, and it says done uploading. So we can close that off now. Okay, so this, just going back to the Wiki page very quickly, that there's a basic sketch example here, not exactly the same as the one that I just showed you there, but very similar, and it goes into a bit more detail about some of the arguments and the construction of some of these messages in the code for use within the Arduino. There you go. There's the log level trace debug info warning and error that we saw in the that we used in the Arduino code. So I've tried to use quite a lot of these in that example just to show you what some of them do, but we're not using, for instance, all of them. We're not using these result ones, because you can actually use a return result for that message. So when you send a message, you can actually interrogate how it believed that message went in terms of its sending. So you can report back that the message result was okay, or there was some illegal issue with the length, or there was an issue with the buffer. So you can build some error checking into your Arduino code if you wish, using these return results. So looking at the Air Manager, let's just open that hardware message port add function. So again, it just gives a very basic example now. Now we're talking Air Manager Lua code now. So if we open, let's just do that before we. Let's just open Air Manager so it opens. Okay. So what we've got within Air Manager then is, again, you create an ID, very similar to what we've done with lots of the other functions so far in the video series. Hardware message port add, so very similar to what you're doing in the Arduino, but you're doing it in Air Manager now. So you're also setting up that link, if you like, and you're saying here Arduino Mega 2560, and you're saying channel A. So you want to do the same here as what you've done in the Arduino. So if you're using A or B or C or D in the Arduino, you need to use the same channel here in your instrument, and then a callback of new message. So similar layout here of the function, and then the callback for new message will return the ID of the message. So within the Arduino, you give it an ID similar to the way that we give it an ID when we send something. So it's kind of a two-way thing, if you remember, and so it does exactly the same as the Arduino code. It also gets back an ID, and it gets back a payload. And so you can, within this code, this particular example just prints the ID number, but you can use your code in here to strip out that payload information and do something with it. And then at the bottom here, a send example. So again, you use that ID that you create here. We're just calling it ID in this example. Hardware message port send ID. This is the this ID, the ID of the message. So you give it a unique number. In our example, remember we were looking at 7 and 8. 7 was the integer one and 8 was the string one, and then this is the payload information. So as it says here in the description, in this case a message with ID 777, that's this bit, with 3 bytes, that's your 1, 2, 3. And that gets sent to the Arduino, and then the Arduino will receive it with its receive function. So totally bidirectional. So let's get Air Manager up here. I've got it open here. Again, similar to what we get with a standard Arduino. In the Devices tab, when you plug it in, it takes 20 or 30 seconds for this to recognize, but you should see your Arduino Mega or your Arduino Uno appear here with the channel number in brackets after it. It is a little different in terms of what it reports. So when you click on it, you'll see that it'll still come up with its title there. It'll still have channel and the channel that you have requested, A in this case. This time, instead of the mode result that we got with the previous standard installer, it now says message port in there. So that's important that you've got that. That now says that this particular Arduino is set up for message port, as that is the mode. And then the state should say connected, just as with the standard installer. So our Mega is being recognized, so that's good. Our flashing was obviously good within the Arduino IDE. So we can come back now to our instrument as our API tutorial again, and this is the code that we've initially got within that instrument. So the first one we're going to look at is receiving something from the Arduino. So the Arduino is going to be the transmitter in this particular case, and the Air Manager instrument is going to be the receiver. So from our Wiki example and the IPA page, we've set up an ID. I've called it something a little bit more meaningful here. So message port ID, and then hardware message port add. You add the message port. You add the name of the message port. So the device is Arduino Mega 2560A. Okay, Arduino Mega 256, and it's channel A. And we're going to call back a function called message callback, MSG callback, which is up here. So our function message callback is going to return the ID of the message coming over message port from the Arduino, and the payload, of course. So what we're going to do is, in this little function here, we're going to look at that payload information, and we're going to strip out what's in there, and we're going to print it. We got some a print in here that we're going to print it to the console, so when we receive it. So essentially what this does here is that looks at all of the information that's in the payload. So I've done it this way so that the payload length could vary. So this basically just iterates around the different payload elements, and we'll keep doing this for loop until there are no more elements. So if there's only 1 or 2, it'll only do this twice. This time we've set up an example where we've got the full 8 elements. So it should iterate around this 8 times and just keep, essentially what it's doing is it's append. So on the first time it will set up this payload string here, and it will use the payload information in the first location. So I've got this iteration of I here, and I'm just going to keep iterating that by 1 each time. So the very first one, so when I equals 1, it's going to put the first bit of information in payload string, and then it's just going to keep appending to payload string the next iteration of I each time, but it's going to put a comma in between the data. So we should see all of the data strung out but comma separated in the console window here. And then it's going to print received message with ID, so we're also going to get the ID information as well from that return. And we had a payload of, and then we're going to append payload string, which is the bit that we've been added all of our data onto. So that will be a big message here, basically with all the information that we got set up. And if you remember, when we were looking at the Arduino IDE, we had those 8 bytes of data from 0 up to 7. So we should see that 0 to 7, if it's correct, appearing in this window here. So let's go ahead and run the instrument. Now, the particular instrument, I've got it here off the screen. There we go. Don't worry about this button too much. That's for the send in the other direction doing. So this actually isn't doing too much at the moment in terms of this particular code. But the important thing to note is our little function where we set up. So I'm going to take the pin here. I've got one end already grounded in the Arduino there in the ground, and it was D7. So if I push that in D7 now, you can see when I've pushed that in there, it's come up with a message now on our console saying received message, which is our print here, with ID 2. That was the ID that we used sending from the Arduino IDE that we programmed. So ID 2 and a payload of 0, 1, 2, 3, 4, 5, 6, 7. They were the 8 bytes of information that we sent. So you can see now how the Arduino you could send whatever bytes of data you wanted to, and this is the manner in which you would receive them. You don't necessarily have to do this. If you know it's a fixed length, then you can just refer to these individual bytes of data explicitly by their position within the array using this payload array. So that's and then when we pull it out again, we should get another thing. So we pull it out and then we get another message. So that was the way the Arduino code was set up to transmit on the change of state of that pin, sends the same message. So what we'll do now is we'll just scroll down a little bit more and we'll look at the information going in the opposite direction. So now what I've got set up is I've got that button that you saw, that red button. This is our button PNG image again, and it's appearing in the middle of our instrument, and it calls this button press function. So within the button press function, whenever we push that red button now with our from our Air Manager instrument, this time we're sending information to the Arduino, and the Arduino obviously needs. So if we had a DAC, for instance, hanging off the end of the message port, we could send some bytes of data to the DAC and get it to send that out. So we've got an analog output capability, or whatever other hardware we needed to be able to write some bytes of data to. Okay, so in this demonstration, all we're going to do is something very simplistic. Is we're just going to turn the internal LED of the Mega on and off, and then we're going to do a string example that I've got commented out here. We're going to do a string example as well, and we're going to see how that that 2-way thing, we can send the string here, and then we can get the Arduino in the code. If you remember, whenever it receives this ID8, it sends a debug message back. So when we send this string, we should get the debug message appearing back in the console here. Let's make that a little bit bigger. Okay, so for the first test, then we're just going to use ID7. Now, if you remember from our Arduino code, ID7 was the sending of some int. So we've got set up just an int array here of just the size of 2. You can see here I've put a comment in here that this data type in here can be just a normal int, an int with a number of elements in the array, float, a float array, a byte array, or that should say string, or it can be a string type, which we're going to show in a minute here. So we're setting up an int with 2 elements, and so those 2 elements that we're now sending here, these are the 2 bits of data. Is we're just sending this variable send int, and we're also sending the number 3. So the send int we're just creating here from this state toggle. So essentially every time we push that button, we're just going to toggle this variable state and flip it between true and false, and then depending on if it's true or false, we're going to set this send int to a 1 or a 0. So we're basically going to send a 1 or a 0 to the Arduino, and then the Arduino is going to receive that 1 or 0 over message port, and it's going to use that 1 or 0 to drive the LED on and off, if you remember our Arduino code. So let's go ahead and run. So now you should see, if we turn just turn the light off here, you'll be able to see the Arduino LED a little bit better. Not the green one that's on there currently, but there should be another one coming on. So when we push the red button here, you see the orange LED has come up there on the Arduino, and then we push it again and it goes off. So on, off, on, off. You can just see one just to the left of that. That's the I think the TX and RX LED. So every time you're communicating with the Arduino from Manager, little messages are just going through. So you just see the blip of those LEDs, but the actual LED that's turning on and off, D13, is that one just in there. So that's, it's quite simple demonstration, but it shows how you can send information backwards and forwards between message port. So let's have a look at the string example. So that was the int, of course. One thing I did forget to say is, and if that's let's move this where we can see it a little bit better, is that these are all the messages and errors. So you can see here, if we stop and we run this again here, you should be able to see how we get the hardware message port messages coming back. So it's saying which Arduino it's coming back from, just in case you've got more than one. And you can see we sent the text error and warning, and how you get the appropriate sign there. And these are all the other different types that we use, but you can see they essentially send the same message. And these are the length and the type, and the date. The 3 was this 3 that we're sending just here, because it was looking at the second element of that int. So that just gives you an example of how you can send back to the console for debugging purposes. So let's have a quick look at the string example now. The string example is just going to send "this is a test." So we'll make sure we save that and we press run here. This time we're sending meshing 8, so we're not sending 7. So the LED shouldn't turn on and off. Let's just make sure that is in fact the case. It's on at the moment. So when I push the button now, you can see, you saw the little blip of the in fact, you can just see them there, the communications LEDs, but you can see our LED D13 is not actually changing state, because we're not sending any messages out on ID7, so the Arduino is not seeing that. It's seeing a message coming from 8, and you can see there, let's just clear that console again. Now we've got all those debug messages in there. So we'll just press this the once to send our string, and you can see there, these are all the debug messages that we had in there before, but rather than now send the result of what the LED is doing, it's printing the message back to the console of whatever text that we've sent. So we sent "this is a test," and it's just sending back "this is a test," and you can see it's got all the upper and lower case there. So exactly as we sent, it's returned it back there to the console. So I think that's pretty much it for the hardware message port. You can see it's very, very powerful. You can do lots of things with it. We only scratched on the surface of it in today's video, but please explore it. It's probably one for more intermediate to advanced users, but if you've got to grips with all the other API functions and you're quite competent in using those, then maybe it's time to, if you have a use for it, and it's not something that's natively supported by the other Air Manager hardware functions, then you can use message port to interface with that piece of hardware. So delve in and have a play with it, and you'll see how powerful it is. Thanks very much for watching. Join us again for another video soon. Cheers, bye.